We are water. We are 70% of our weight is water. 70% of me is water. 70% of you is water. Water is one of the most efficient solvents on the planet. It solves almost everything. Water regulates our body temperature. Same thing for the planet. It's mind-boggling. When you think about these physical properties, you go like, I get it. It's a pretty amazing material. And if I want to find another one to replace it, well, the list will be quite short. Okay, so I have an experiment here. I need volunteers. I would like 2 guys and 2 women, please. You're going to get air balloon. You're going to get, we have a 2 liter. I'm sorry, you're going to be out. It's an experiment about the heat capacity of water. So you're going to hold it with the tail. You're going to hold it with the tail. You guys are the atmosphere. You guys are the ocean. And I have the sun here. Are you ready? Yep. So this is the power of the sun. Here's the atmosphere, and we warm up the atmosphere. It popped. This balloon is much better. I bought it at a different store, so it's probably not going to pop. No, it's not going to work. So now we're going to do with the ocean. Step a little bit aside. This experiment is not completely safe. And we're going to warm up the ocean. Come on, pop. Oh, well, we're gonna do it with this one. Maybe it's gonna pop. My balloon is pretty good, huh? All the heat from that flame is absorbed by the water, right? So it doesn't pop. All right, that was. Thank you very much, ladies. I'm going to ask you this first question here. Which of the following take the most amount of water? Running a dishwasher for a month, manufacturing a cotton shirt, making a steak, or 1 cup of coffee?
If your answer is not correct, you will count against your participation. No, just kidding. It's okay to make mistakes, it's good to make mistakes.
In science, we often make mistakes. That's how we learn. It's important to be able to say what you know, but also what you don't know. For example, when I got into this and was surprised by the rate of ice melting in the ocean, the glaciologist tradition was, no, ice doesn't melt in the ocean, it freezes. But until someone studied it, it was, no, that's not possible. Ice freezes the ocean. Well, apparently not.
You want to try? Oh, you did? Okay, good.
I'm just going to say it's not necessarily easy to be a scientist being a woman. Plus, if you're married with someone, there's one, he's 8 years older than me, so, in 8 years. Stay. Go, run. Yes. Go.
Go, girl. Go.
I use satellite data to study how the ice sheet, Antarctica and Greenland, are evolving and how they are losing mass and are increasing sea level. It's called Grace, like the dog. The dog was adopted and it was renamed Grace after the mission.
There's a ball here. Look, a ball.
I don't know if she won the ball. Here, Grace.
You get people's attention when you sort of convey the idea that this place is going to look different, a little bit lost forever. what you grew up with is going to be destroyed. Then they start listening.
Also to connect it with something in their life, it's like something that is real, not something that happened on the other side of the world. So they have to be aware of the threat, and they can see that they can do something, because that helps empower people.
The transition offering to humanity is actually a transition for something better. We don't have to tighten our belt. There's not going to be a large economic cost, but something is more clear now. You can do it and actually save money and live in a better place. So you have to be positive, because the outcome is positive. It's not a lullaby, it's in a way a better world. But making that transition is tough. To see parts of West Antarctica collapsing and parts of East Antarctica waking up, this is a huge deal. At the end of the day, whether you're optimistic or pessimistic, I don't care.
As long as someone does something.
What do you do?
Yes.
Right? Albert Camus was saying in La Peste, we do our job. What can we do in this situation of crisis? We do our job. We're scientists, we're doing science. Now, we can take a different hat and talk about the impacts and policy, but fundamentally, we're scientists, we're not policymakers. We're not going to tell policymakers what they should do.
No.
We can tell them, hey, there's a big problem here.
How you like that landing?
Fantastic.
Hello, Bill.
Hello, how are you?
Fine. Very fine.
Okay, let's load and go. Yeah, the strong guy's at the back.
Morning.
Hello. Are you sleeping? Nobody? You sleeping?
I think so.
Yeah, really?
Maybe he has earplugs?
Whoa.
Eric? It's Didier. You okay? Doesn't sound good. Have you been up all night?
Wow, it's you. What time is it?
Midday.
No way.
Yes?
Good grief. See, I'm exhausted.
We've got 3 hours to load all the gear.
Yeah, I know, we're late. It's a real shit show.
I'll let you wake up. Come on. Right.
Oh, I was not ready for this. I did not expect these cold temperatures, very cold weather on Petermann the whole time, minus 25 degrees C and wind, so it was more than minus 25 C. It was a difficult conditions, which at the beginning of the spring season, end of the winter, is a little bit unusual.
There's a kovac to make the hole?
I've got everything.
So did you check?
I've got everything.
There's room?
I've got everything, Eric.
There is?
Yes. You need your crampons and helmet. You've got your ice axe too in the front. Hot water here. Bring your flask. Did you bring any bars, something to eat? Here you go.
I know him for a very long time. I met him when we were students, and it's a very, very good friend, and we have a strong relationship. We did so many adventures together in mountain or at sea and sailing.
Setting up 2 radars in the heart of the glacier isn't so easy. I'm a bit worried. We're on a schedule. We need to finish before the plane leaves.
Eric loves to know guys very well. It's the reason why I think he chose me for that very small expedition, and he trusts me.
Eric, if you hit a hole, just jump off. Forget the sled. Your safety comes first.
Will do.
Wait, I'm missing my ice picks. Where are they? All good?
Clear your back.
All good. Here, if you go through the middle, we'll get stuck.
You reckon?
For sure. It's really deep.
What about the first bit?
You'll see.
You think it's risky?
Well,
Let's give it a go.
come on.
The Greenland is the boundary between the ice and the ocean. It marks the first time where ice is not sliding on bedrock, on sediment anymore, but it's sliding on seawater. It's underneath several hundred meters of ice, so you don't see it. It's an elusive point for us on the ground.
Does this look clean?
Okay, so we've got the seabed like that. So all of this is the bed. And here you've got the water line, the sea level. And then the glacier here, you've got the front, and the glacier is rising. On the under part of the glacier, it goes like that. And basically, here you've got a point where the glacier, which here was touching the ground, here doesn't touch anymore. There is a bit of gap. And this point, you can find it on the surface because it's a place where the glacier flexes with every tide. We cannot know for certain how thick is this cavity, but just right here, this piece of the glacier goes up and down, and the water can enter and go out, and at every tide, it's a bit like a heartbeat. When it opens, when the tide goes up, it opens further in, so the water can go further in. And then when the tide goes out, the flow goes out as well. And that is a bit like when you stir the sugar in your coffee, you help it dissolve. So here that flow will help the glacier to melt.
To me, it's the most important boundary. That's where everything happens. We thought for a long time that that boundary was just a few hundred meters, And from the satellite data now we see that it's not uncommon to have this flushing zone to be kilometers. And that's kind of a game changer for glacier dynamics, because that means if the ocean waters get warmer, they will affect a large range of glacier ice as opposed to a narrow range, so they will have more impact on the glaciers.
Damn thing. Where is it shallower? Hard to tell.
Are you stuck?
Yeah.
Holy shit. Easy does it. Eric.
I'm fed up.
1, 2. 1, 2. Okay, I'll try again. I saw the cable move. I'm fine. Come on, let's not waste time. Stand in the back, knees here, feet like this, ready to jump. Hold an ice axe in one hand, okay?
Yeah, good.
Make sure you don't lose it.
It keeps flying off. We're making progress.
We'll head for the plateau there, right?
Yeah, I think so.
After that, it's full of crevices.
You need a pretty flat area, so that's good.
Okay. I only see one pick.
Shit.
Did it slip?
Yeah.
Well, we'll find it on the way down. So...
The APUS is a device that you deploy on the ground that has a miniature radar depth sounder.
It isn't working.
We haven't had a chance to observe a lot of this environment before. That measures the return from the different layers in the ice all the way to the bottom constantly with high resolution, so a lot of details. And with that, we can keep track of where the ice bottom is with time. So we can measure the melt rate in real time, and we can also measure it over a long period of time. And we want to be able to see very small changes of the order of centimeters per day or meters per year.
We'll film ourselves.
Come on, dude. Yes. All right, let's have some fun.
We're having a laugh, but...
It may not work, but we've had a lot of fun.
We're exhausted.
Let's keep our fingers crossed that it'll work.
Yeah.
We haven't finished analyzing all these results. My colleague Keith Nichols is looking at that, but initially he found some very high melt rates. And I'm not going to quote some numbers because they seem to be changing with time. But they at least testify that this is an area where the seawater is able to intrude, rush under the grounded ice and melt it very, very vigorously. So that's pretty exciting. That confirms that this grounding zone is really important to the dynamics of the glacier.
You want to try take the bridge?
I mean, to see if at least you can see a bit of the lake.
Try to acquire at least 12 hours of data in one mode, otherwise if it changes all the time, it's not going to stay coherent.
We'll be in touch, and at least we are saving the data. And
Okay, and take some breaks, eat some food, with plenty of fluid. So remember, Monday the weather starts degrading, and Tuesday is bad weather. So that means overcast, and then maybe a little bit of wind. 8 to 10 knots is okay. It's not dangerous, but it's colder. And we expect that when we call you, there's always someone answering, or else we're going to start worrying. But you're fine. It's beautiful. Enjoy the landscape too. It's a treat to be here.
Will do.
It would be enough behind, I guess.
He forgot to tell us to fasten our seatbelts. It always leaves me perplexed. You see these icebergs and you know they've already had several lives. So much happened to them before they got here. You don't know when they broke off, what happened to them, how many times they've turned over or broken, etc.
This one behind me here is completely... it's shaped like a rocky cliff with faults. If that boulder breaks off up there...
We'll be in trouble. We're in the danger zone now. A gust of wind will send ice projectiles flying, with cannonballs coming at us the moment the thing explodes. They'll go right through the side of the boat. Right through us. It's very dangerous.
Jakobshavn, if all the ice drained by this glacier would melt down to sea, it would raise global sea level by 50 centimeters, half a meter, one glacier. Well, it's the largest glacier in Greenland, and the base of the glacier remains below sea level very, very far inland. So it will always stay in contact with the ocean. Glaciers hate the ocean. They melt like crazy in salty water. They don't like it. When I started my career in the early 90s, we were going to measure the thickness of this glacier. A lot of technology was developed to measure the thickness of this glacier. We still don't know it. We still don't. Near the grounding line, we're not sure. And you don't want to walk on that glacier. We can walk on Petermann. On this one, you cannot walk. It's chaos, total chaos. You have pinnacles, seracs everywhere, ready to fall. And they fall all the time. So you don't want to go there. You have to be nuts to go walk on the glacier like that.
Friction. Look at that. Good as new.
You're a pro. All done here, I hope?
You didn't finish the dishes. Just because you made a bowl, it doesn't mean you finished the dishes.
I made a bowl.
Shall we eat noodles?
Where's the bowl?
You're gonna do that?
I can do it. I will try it.
Okay.
5-star bowler. Maybe you should put some water in.
Soy sauce. You need soy sauce.
No pressure, Gary. Just
This is the team. 1 working, 3 watching.
you're the best, Gary.
Okay.
I have a different background. Like my undergrad was in ship design. Then I have a master's in, again, ship hydrodynamics and applied math. I worked a couple of months in parallel computing, then some data science, then data assimilation, and finally I am here in the field of glaciology. I think it took some time for me to come here, but eventually I'm here. And I like it, absolutely, every bit of it.
You feel like you belong here now.
Oh yeah, it's pretty beautiful. It's a different feeling when you actually see what you're working on. It gives you an impression, this is what I was seeing in the data, and now I see it here clearly. It's a wonderful experience. I would say, I like it. I get a chance to, work on the pressing problem, that's climate change. I think we all have to take it very seriously. We actually need to consider it more seriously, and I get a chance to work on this problem. That makes me feel happy.
More? Or is that okay?
That's fine. It's romantic to eat out, but we're freezing our butts off.
Isn't Benjamin eating?
Coming.
Did he tell you? When I got out of the plane, it was cracking. There's a bit of water under the ice building up.
Amazing. It's been minus 17 for the last few days.
One of the first early work I heard about somebody drilling a hole and exploring what's happening in an ice shelf was Olaf Orheim, who went into a rift zone and drilled through it, notably because the ice was particularly thin there, so it was not a major effort to drill it and at a point of access to the ocean. But sort of demonstrated to me these places could be safe to operate.
So we're going to take a little tour up there to see, well, just to see. We don't know what we'll find because nobody's ever been up here. It's a real thrill. Only science pushes you to do things like this. That's the beauty of it. A few holes here. There are blocks on top of each other here. It's cracking. Look at that. Crikey. Now this is what I mean.
Wow! Woo.
It's cracking all over. It's huge. You have to realize that it moves about 3 meters a day. It's moving all the time, cracking every minute. You need to see this. Just you wait, it's worth it.
How are you doing?
All right.
Okay, well, I'd like 2 cheeseburgers and a barbecue sandwich.
All right, 2 cheeseburgers and a barbecue sandwich.
There are American flags everywhere. Next to Al Gore's farm. Maybe he comes to eat here occasionally.
It's your start. I'm a third. And we're gonna be on what?
So he's doing polar science. He's going to Greenland and Antarctica. How do you imagine these countries?
Oh, this country? Great.
No, I mean these places, Greenland and Antarctica. How do you picture them?
Where?
Greenland or Antarctica?
I don't know. I got a lady friend from Brazil.
Brazil?
I got a Facebook friend from Fiji Islands.
If he'd been elected, which actually he was, we could have saved time. But these things don't happen just because the president wants them to. There has to be support of Congress, the Senate. You need public support too. And at the time, he should have been president. Even members of the scientific community were a little hesitant. Things started to change around that time, but it wasn't clear-cut, even then. So somewhere along the line, he'd have come a bit too soon. We've reached the farm.
Eric! Welcome, welcome.
Mr. Vice President.
Glad you could come to the farm.
So good to see you.
Good to see you, my friend.
Thank
Long
you
time no
so
see.
much for getting us here.
Of course. How are you?
I'm very good.
Great.
Welcome to your home.
Come on in.
I love your boots.
Well, I've had them for 40 years, so
They're shaped to my feet. Well, they're very comfortable.
What about you? I saw your intervention in Davos.
Oh.
Very punchy.
Well, the times call for it, I think. It's coming along extremely well. We are using artificial intelligence in order to precisely identify where the global warming pollution is coming from.
Yes.
It is showing that the oil and gas industry's emissions are 3 times larger than what they've been reporting to the public.
3 times.
3 times as large. But now we will be able to show the public whether they're following through on their pledges or not. As the world summons its collective willpower to say we've got to reduce these emissions, hopefully it'll make it easier to get that done.
So now we have the stick to tell people if they're doing good or not. We have to find the carrots to reward those who are doing a good job, right?
But the data now shows that once we reach net zero, true net zero, temperatures on the Earth will stop going up with a lag time of as little as 3 to 5 years. That's astonishing. It's almost like flipping a switch. So when they talk about carbon removal from the atmosphere, the best way to remove it is to stop putting it up there and let it fall out.
Yes, yes. And 3 to 5 years is like a political term. So you can get the benefits of that.
Absolutely. That's within the span of one American president's electoral term in office. So that's an incentive.
Yeah, so that was wonderful news. It's just when you look at these IPCC reports and what is needed, it's a drastic change we have to go through, not just a little plateau.
Yeah. Mother Nature is now sending more powerful messages than any of us as activists can send. Unfortunately, the extreme climate-related disastrous events are getting more numerous and more serious. But my optimism is based on the assumption that we are now in the process of waking up in the world. So it is a political battle.
Told me if you ever need some news, some update.
Thank you.
What Grace is saying in the following.
I slept 5 hours last night. Once my feet had warmed up, I was away in 10 minutes.
Did you give it a name?
Well, I call it the Grove. Some call it the Minion, because it has a little round yellow head.
The climate change is not like a field of science per se, it's like a super field. You cannot do climate change science without so many different types of scientists. I think almost all of them will be included. Like you got physicians, oceanographers, biologists, people looking at astronomy, mathematicians, but you could get also economy and everything. I mean, I could just keep going, like every single field, because we are all on Earth at the end, and it's impacting almost everything. There's countless type of research that are necessary for moving forward in our comprehension of the climate situation.
We could have made a list of the 10 things that are going to go wrong and are going to make it impossible for us to get any data. We got snowed in, we had a storm, complete whiteout, which I had never seen before. This is the kind of situation where we could have been stranded for several days or even weeks if the weather stayed like that.